All right, what's up, y'all? My name is Charles McNabb, and this is my lab 2 report. So, this lab was pretty similar to lab 1 that we did a couple weeks back, only this time, instead of assuming that the tape is a point charge, we're actually calculating that charge as a distributed charge, as like a line of tape with uniformly distributed charges. And so the experiment itself that we did was the exact same. You could pretty much just use your data from Lab One. Only this time, the modeling and the actual coding was altered and a little bit more complex. But we'll get into that later. Running through some Lab One stuff real quick. The length of the tape that we used was 20 centimeters, and then that mass was 2 times 10 to the negative 4 kilograms. And then our tape was positively charged. Figure this out through the hair test with a pen, whatever that was. But yeah, and then we found through the floating tape experiment that our tape began to float at a separation of 2.5 centimeters. Now we were able to use sum of forces equations to go and find the charge on one piece of tape, which we found to be 1.17 times 10 to the negative 8 coulombs, and then the total number of electrons could then be calculated from that. We got 7.3 times 10 to the 10 electrons. And just some assumptions that we made here were to ignore air resistance first off, factoring into the sum of forces equation, and then assume that each piece of tape has the same amount of charge that is evenly distributed along the length of tape. Now, this is pretty much the start of the code. We use this in Lab 0 and Lab 1. This is just something to find the electric field of a point charge. Super simple. You could pretty much just copy that back over. But yeah, pretty standard. Next, here we are defining the tape as a line of point charges. This is where the lab really begins to differ from Lab 1. Here we define it as a line of point charges instead of just a single point charge. And so, yeah, a lot of this code was actually given to us. We were given more of a skeleton code and then just had to work through that and make additions here and there to make that code viable and make it represent the model we really wanted to represent. But yeah. And then here we are actually creating the model. We had to edit a few things here and there, really with just scaling and especially getting those arrows right and making them look how they're supposed to look. And so pretty much anywhere where it says edit the next line, I made like a little change here and there, adding some products in there, just multiply some stuff out and make those arrows look just a little bit nicer. Now here is the actual model itself. As you can see, we have our 2 pieces of tape as a line of point charges with fields and forces represented there. Pretty cool stuff, actually. I was really happy that this turned out the way that it did. Now, some important questions to kind of go over. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated charge values that you got with each model. Now, so if you modeled it as a single point charge, the value of the charge might be the same as the one found in Lab 1. However, the value of the charge on the tape with the line charge model was greater than what we originally found, and that was by a value of 2.66 times 10 to the negative 9 coulombs. Microscopic, but hey, there's a difference. And then, why do these values differ? Which is more likely to be closer to the real value? So, these differ because when you assume that you have give me a second, let me recollect here. When you're assuming it just as a single point charge, that doesn't accurately represent how that piece of tape interacts with the world around it. This is really a whole series of charges distributed amongst that tape in 3D space. And so if you model it simply as a point charge, then of course you're just going to get different values. And that means that the actual line of point charges distributed here is far closer to accuracy. So yeah, that kind of does it. I will include the link to my code in the submission.